Good to be back again with you with a new concept. Today we are doing polar and non-polar covalent compounds. Well, talking about covalent compounds, how do they have polarity? Right? Anyway, before we proceed, I am Monica and let us take some baby steps towards understanding the concept. Now, it's important for us to know what bond pair and lone pairs of electrons are. So let's get an idea about it. So here taking an example of water molecule. Let's take an example of water molecule here. Alright. Now, so water molecule has one oxygen atom and it has two hydrogen atoms. Oxygen having 6 valence electrons, so 1, 2, 3, 4, 5 and 6. Hydrogen has 1 valence electron, so 1 and 1 here. So both trying to complete their stability, that means hydrogen trying to attain the state of duplet, oxygen trying to attain the state of octet. So what has happened? This has happened. Now oxygen has 6 already, 6 electrons already. It needs 2 more. So what it does is shares it with its neighboring hydrogen atoms. Well, they are stable now. So what has happened in the process? Hydrogen, single bond, oxygen, single bond, hydrogen. Right? So what are these single bonds? What are these single bonds here? They are bonded electron pairs. That means they have participated in the bond formation. So that is what is said to be the bond pair of electrons, right? So the bond pair of electrons are those which have participated in the bond formation. Well, you have more electrons which have not participated in the bond formation. Take a look. So if you look at this electron and this electron pair, they are valence electrons which have not participated in the bond formation. Well, that is what is called the lone pair of electrons. So lone pair of electrons don't participate in the bond formation. So looking at the water molecule, you will see that this and this, they are the lone pairs of electrons which have not participated in the bond formation. Whereas if you look at this and this, they are the bond pairs of electrons in a molecule of water. Now take a look at the hydrogen molecule. 2 hydrogen atoms bonding together and 1 electron pair being shared. Does it have a lone pair of electrons? Well, it does not. There is no lone pair of electron available here. Take a look at hydrogen chloride. So you only have 1 bond pair of electrons. However, there are 3 lone pairs of electrons. 1, 2, 3. Right? So they have not participated in the bond formation. So I hope you have understood what lone pairs of electrons and what bond pairs of electrons are. Now what we will try and understand here is how do they contribute in the polarity of the molecule. Let's take a look at this. So we have an example of hydrogen chloride here. Now, hydrogen chloride has 1 hydrogen atom and has 1 chlorine atom. Correct? 1 valence electron and we have 1, 2, 3, 4, 5, 6, 7 valence electrons. So what has happened? We have 1 bond pair of electrons existing between hydrogen and chlorine. Well, we have discussed the fact that different elements have different electronegativities. Remember that? So what will happen? What if they have different electronegativities? Which of these has more electronegativity? Chlorine is more electronegative. So what happens then? Chlorine is pulling onto the bond pair, so is hydrogen. So they are having a tug of war here. Chlorine pulling onto the bonded pair, hydrogen pulling onto the bonded pair. So what has happened? Who wins? Well, chlorine wins. Why does it win? Because it has greater electronegativity. So the atom which has higher electronegativity is able to pull the bonded pair more towards itself. Right? So when it is pulling more towards itself, the bonded pair, it creates a force within the molecule. So that pull is because of the force, right? Pull is a force. So what is happening in the process? So this bonded pair is pulled more towards the electronegative atom. And this is what is creating the polarity. So when the bonded pair is pulled more towards the chlorine atom, it creates a partial negative polarity on the chlorine atom because it is more electronegative, and a partial positive polarity on the hydrogen atom, right? So which is what is making hydrogen chloride a polar covalent compound, right? Let us try to understand it further. Let us take an example of water molecule. Okay, so water molecule again has oxygen, which is more electronegative as compared to the electropositive hydrogen atoms. So what happens now? The bond which exists between, let me use a different color. So the bond which is existing between the oxygen and hydrogen is being pulled more towards the electronegative atom, that means pulled more towards oxygen, and this is what is giving a polarity to these oxygen and hydrogen atoms, wherein oxygen, which is more electronegative, develops a partial negative polarity. However, a partial positive polarity develops on these hydrogen atoms, and therefore we can say that there is a net force which is pulling the bonded pair in a particular direction. So what is this net force? This net force is what is called the dipole moment. So dipole moment is the force which is created within a covalent compound molecule, wherein the more electronegative atom is pulling on to this bonded pair of electrons with a greater force. So the one with a greater force is naturally the winner here. Okay, so the net dipole moment is more towards chlorine. The net dipole moment here is more towards oxygen, right? So that's the dipole moment. Now if you take an example of, let us take an example of okay, here. So we are taking examples of methane and carbon dioxide molecule. Let's see what happens. So in a methane molecule, how is it different? How are things different? Alright. So if you look at a methane molecule, there is a symmetrical arrangement of hydrogen atoms from all four sides. So it is a tetrahedral symmetrical molecule wherein hydrogens are symmetrically arranged on all four sides. So carbon has, in general, carbon is more electronegative as compared to hydrogen. So what will happen if it is more electronegative? It is pulling the bonded pair more towards itself. So here also is the same direction of dipole moment, right, between the carbon and hydrogen atoms independently. So the net effect within the molecule is what? Four equal forces from opposite ends creating a net dipole moment of 0. So if the net dipole moment within the molecule is becoming 0, well, there is no polarity, right? So the polarity was only because of the fact that the net force happened to happen in one particular direction. Well, here because it is being pulled on from all four sides with equal amount of force, the net dipole moment is 0. So methane is a non-polar covalent compound. Now take an example of carbon dioxide. Here is the same format of understanding. The only difference lies in the fact that here we had a tetrahedral structure, here we have a linear structure. Now if you look at carbon and oxygen, well, carbon is more electropositive as compared to oxygen, meaning that oxygen is more electronegative. So naturally the dipole moment is more towards oxygen, right? Now if you have two equal forces from two opposite sides, the dipole moment is 0. So if the dipole moment is 0, well, there is no polarity, right? So this carbon dioxide also is a non-polar covalent compound. Now generally what happens is, if you have two same kinds of atoms bonding, so hydrogen bonding with so hydrogen bonding with hydrogen, so what will happen? You will have, the kind of force which will be created, because this also has the same electronegativity, this also has the same electronegativity. So the bonded pair is being pulled upon by equal strengths. So naturally there will be no polarity in a molecule of same atoms, right? So the polarity, if it has to exist, has to happen between two different types of atoms because they will have differences in their electronegativities, and yet they may end up having no polarity. So there was an electronegativity difference between carbon and hydrogen, wherein carbon was more electronegative. However, the difference was small, and at the same time, the dipole moment which was happening within the molecule was zero because it was equal from all four sides. And here also, because it was equal, the dipole moment was equal from both the sides, the net dipole moment was zero. So there was no polarity within the molecule. I hope you have got the concept, and if you have, please remember to like it. I love your motivation any which way, right? And will certainly appreciate your candid feedbacks. You have your subscription button at your hand tips, right? So please remember to press it so that we can stay connected with better videos to come. Also remember to share it with your friends who may benefit from these videos. Hope to see you connected. Okay, bye bye.